Hello, and welcome to Lesson 3 of P.2, the AFAR unit, where we explore forces, stability, and change. I'm Marielle Kolker, a high school physics teacher who piloted and teaches this lesson and an OpenSciEd facilitator. In this video, I will give an overview of Lesson 3 and wrap up with some tips and tricks. This lesson is important because we make progress on identifying the relationships between matter, energy, and force through the behavior of matter that isn't too big, like tectonic plates, and isn't too small, like the atoms that it is comprised of. Let's begin with how we got here. During Lesson 2, we experimented with forces on foam plates and experienced the cycle of stability to change back to stability. We figured out that unbalanced forces are associated with change in motion, and balanced forces are associated with stability or equilibrium. Let's start by taking a look at the lesson as a whole. This one-day lesson helps us develop the matter-energy-force framework to include energy that can be stored in and transferred into or out of matter. Even though it is labeled as an investigation, it is in the form of watching a teacher demonstration. There is no hands-on activity here. There is also a reading about forces on matter that helps bridge to the next lesson. So this one-day lesson contains one sense-making loop in which we continue to develop our understanding of the relationships among matter, energy, and forces. We use a foam model to explain how forces cause matter to change, and we begin to understand how energy transfer is also involved. Then we consider related phenomena through an article about matter changes and use that to make claims in response to additional sense-making questions. In sum, this lesson helps us develop our MEF framework by introducing energy transfer and by giving us some insights into how materials behave under external forces. Now I'll take you through some key moments. So part 3 involves a demonstration of forces on matter using a foam cantilever, which is a long piece of foam attached to the edge of a table. We used this foam as a model for continental plates in Lesson 2 as well. In this lesson, we are focusing on changes to the matter as forces become unbalanced and return to being balanced. By dividing the activity into 5 moments in time, students are able to focus more closely on what is happening when matter is changing or moving. We add our observations of both matter and forces to our explaining the behavior of the matter in the system poster. This sets us up to begin evaluating energy transfer. So in part 4, which is also with the cantilever, students identify where energy is transferring in or out of the foam system. This was rather intuitive for my students as the foam performs like a spring in that you can compress it, or in this case, bend it, and then release it. Students can clearly see the deformation when energy is being transferred in or out. In my class, we also recorded energy stored in the center column of the poster. Parts 3 and 4 are important because they help students think through the relationships between unbalanced and balanced forces, the stability or change in matter, and energy transfers before we add them to the MEF poster. By the end of Lesson 3, we have connected matter, energy, and forces at a macro level and learn about how matter is affected by unbalanced forces. This motivates us to figure out how a solid object can compress, stretch, and break under force, and whether this could be happening to tectonic plates. Let's take a look at some tips and tricks now. The actual size of the foam for the demo isn't all that important as long as you get the intended effect. The teacher edition calls for a 1 foot by 2 foot board, but you can be as small as 3 inches by 9 inches. You will want to test it out beforehand, of course, to make sure that it's performing as you need it to. Notice that the foam edge in this image is cut on the edge to 80 degrees instead of 90 degrees. It's a slight angle that allows the board to curve upward when pushed on and compressed. For the construction of explaining the behavior of matter in the system poster, which is at the top right, I duplicated the chart on an 8.5 by 11 paper that students filled out in pairs throughout the foam demonstrations. Afterward, we reviewed and reasoned through their answers and then added them to the poster. I had a lot of success with this method and felt that it was more effective than having students just think about it and then wait until we put it together, because it gave students an active part in figuring out what was happening in pairs before we started talking as a group. While construction of the MEF poster throughout lessons 2, 3, and 4, the best way to do this is to write out each edition on an index card with tape on the back so you can remove it and then put it back for each period. These vocabulary terms all come from the Analyzing Rock Behavior article which talks about matter compressing and expanding. In this reading and the accompanying analysis questions, students are introduced to these material science terms and their meanings. While this is part of the sense-making loop, it did not highlight it as a key moment because it's self-explanatory, that it ends the unit and it motivates us to take a look inside matter to see how it can compress as forces are applied. This is the second of the 3 lessons in which we develop our matter energy force poster. We will complete it in the next lesson, lesson 4. Now that we have examined matter, energy, and forces at a macroscopic scale, we move on to the atomic scale and examine how matter is changed internally by forces and energy. Thanks for watching.